Welcome. I'm Nicole, and I'll be your instructor for this course. Thank you guys so much for enrolling. I am SAP certified in the production planning and manufacturing areas of SAP. I've been working in SAP for about 17 years now, and my experience ranges from initially being a super user on my first implementation project to now being an independent consultant. I have supported clients in many industries ranging from med device to electronics manufacturers, all of which required unique support with their planning and procurement functions. As you know, this course will cover the fundamentals of planning in SAP, but specifically we'll cover a high-level overview of all the planning functions. Then we'll build on that and discuss the relationships between supply and demand, the most basic principle of planning. Next, we'll take a deeper dive into demand planning, which should transition nicely into the basics of MRP. And finally, we'll wrap up the course by covering an alternative planning method known as reorder point planning. When finished with this course, you should understand the overall planning functions in SAP. And of course, the basics of MRP. With the planning overview understood, let's now discuss the concept of supply and demand, which is the real foundation of the planning functions. And everything centers around available inventory. As we saw in the last section, demand, whether real demand or forecasted demand, will reduce the inventory currently on hand for a given material. When that inventory is consumed to the point where available inventory is below zero, or perhaps below safety stock, then the planning engine will generate supply signals to keep the inventory replenished. There are many complex aspects of planning, but in the end, it really boils down to this simple fundamental element. So what are the types of demand? In SAP, there are two basic types of demand, independent and dependent. Independent demand is literally that, demand that is not dependent on anything. This demand originates outside the plant or outside the organization. The two most common examples of independent demand are the forecast and actual customer orders. The demand in these cases comes from an external customer wanting the product or services offered by the organization. Dependent demand is demand created based on the independent demand signals. This relationship is maintained through the creation of a bill of materials. So, for example, in order to sell a widget to the customer, the organization needs to make it first. And in order to make the widget, 2 gadgets are required. We have just learned that forecast is a type of independent demand. And here's a great example of how that looks in SAP. The rows labeled VSF are forecasted demand for this material. Once the forecast is finalized through the demand planning process, like we discussed earlier, it is loaded into SAP. SAP refers to forecast as a planned independent requirement, or PIR. The PIRs are loaded into period-based buckets based on your organization's needs, but a weekly period or monthly period is pretty typical. Standard SAP will start a week on a Monday, unless that Monday is designated as a holiday through your company's plant calendar. And when forecast is loaded, the quantity is pegged to the first day of that period. And again, if loading in weekly periods, the first day of a weekly period will be the Monday. What's important to note here is that the forecast, again, simply represents a placeholder for when the organization expects to sell product to a customer, any customer, and in which quantities. And because forecast is a demand element, the available inventory quantity will be reduced with each forecasted period. Another visual example of independent demand is actual orders from your customers. Because the forecast is simply a placeholder for those orders, it's important to understand forecast consumption. As orders come into the SAP system, the planning engine will consume the forecast quantities that align with the shipment date of the customer order. This ensures that the demand quantity is not doubled up. As you can see in this example, the original forecast quantity for week 21 was 23 eaches. The customer order came through for 11 eaches, which reduced the forecasted quantity from 23 to 12. Consumption can be a tricky concept, so I won't go into too much detail in this course. Just know that forecast is consumed by actual customer orders, and the parameters that control the consumption are maintained on the material master record. Now let's consider a dependent demand example. As I stated earlier, dependent demand is a relationship that's defined through the creation of a bill of materials. In this example, the company will manufacture the test material assembly. And to do that, the company will need to use 10 eaches of the test component and 3 eaches of the test component 2. The finished good will have independent demand driving requirements to these lower level components. As you see here, a dependent demand signal coming from test material indicates that 170 eaches are required for this test component on March 31st. That is because of the forecasted demand or the actual customer orders in the system for the finished assembly. At this point, whether there's enough inventory available for the component on that date is not really the point. Let's just consider the relationship between the independent demand signal responsible for the dependent demand signal. We just covered the types of demand, but now let's consider the types of supply. The two main types of supply are internal and external, with internal being activities such as procuring materials from another plant within your organization, and most commonly procuring material from your shop floor, also known as manufacturing. External procurement is pretty self-explanatory. This is the function of procuring material from an external supplier, but could also represent the purchasing of materials through a contract manufacturer. Let's consider internal procurement, where you might procure a material from another plant within your organization. This is done through stock transport orders, which is really just a special type of purchase order that represents an intercompany or intra-company relationship. STOs are pretty unique in that technically they represent both supply and demand, but which depends on the plant you are viewing. For the ordering plant, the STO will increase available inventory as a supply signal. You can see in this screenshot, the test component 2 is procured into plant 0001 from plant 0005. Production orders are probably the most common form of internal procurement. And again, internal implies you're procuring material from inside your own organization. The finished good test material is manufactured in plant 0001, and therefore the production order elements are the supply elements shown. Supply, or receipt elements, will always increase available inventory. The most common form of external procurement is simply purchasing a material from an external supplier or vendor, and this is done through purchase orders. Because purchase orders are a receipt element, very much like production orders, the elements will increase available inventory. Let's take a closer look at the demand planning functions. Most organizations use 1 or 2 strategies for demand planning. There are definitely more than 2, but these are the most common strategies available. The first demand planning strategy option is make to stock. And if your company uses this strategy, it's because you intend to produce the product ahead of time and place the product in inventory where it's available if and when a customer order arrives. This strategy requires the use of a forecast. A great example of this is the automobile industry. A forecast will predict sales over the planning horizon, which simply means your company is not trying to predict customer sales from now until the end of time, but rather now through a defined period of time. A planning horizon for most organizations is usually somewhere between 18 and 24 months. But sales quantities that are forecasted next week, for example, are probably a lot more accurate than those predicted closer to the end of the horizon. The second most common demand planning strategy is make to order. And this strategy is fundamentally different than the make-to-stock because forecasts are not used at all. In this strategy, the company will only produce product when a customer order is received. Because MTO uses firm customer orders, it implies that the product is not readily available on the shelf to fulfill a customer order, and instead has to be produced. This type of strategy can definitely keep inventory low, but is really only useful for scenarios or customers that do not require immediate fulfillment of the order. Think about the airplane industry. There aren't dealerships on every corner with tons of airplanes sitting around waiting for someone to walk in and buy one. No, these are only manufactured once an order arrives from a customer. Now let's consider MRP. I mentioned earlier that MRP is a production planning, production scheduling, and inventory control system that is used to manage manufacturing and procurement functions within a company. But what does that really mean? That means that MRP is the engine which drives requirements down from the highest level finished good down through to each necessary component through the BOM relationship. MRP is where dependent demand signals are evaluated against available inventory by applying that simple calculation we looked at earlier. In short, MRP is the means by which organizations ensure that material is available for customers and for production while trying to ensure the lowest possible inventory level. Well, why does maintaining a low level of inventory matter? Because inventory is a liability for a company, and when financial statements are prepared, the inventory cost associated with the inventory sitting around the warehouse can have a dramatic impact on the bottom line of the company. Just a few benefits of using MRP within the SAP system are less inventory on hand at any given time, flexibility to respond to changes in supply and demand because of visibility throughout the planning horizon, and being able to see potential issues before they become real problems. And if used correctly, planners should see an increase in their productivity, mainly because they are focusing on the things that matter instead of constant firefighting. Let's consider that diagram from earlier to get a clearer picture of MRP. Again, it all comes down to how supply and demand impact the available inventory on any given day. The planning engine will start with a beginning inventory count every single day. From there, the available inventory quantity is reduced by the demand in the system over the planning horizon. And when inventory drops below some threshold, either a defined safety stock, reorder point, or absolute zero, the planning engine will automatically create replenishments or receipts for that material. And each day over the planning horizon will have a predicted ending inventory quantity. The first key concept I want to emphasize is that demand, or requirements, will reduce available inventory continuously over the planning horizon. The second key concept to emphasize is that supply, or receipts, will increase available inventory over the planning horizon. And the final key concept is that the ending inventory in one period will become the beginning inventory for the next. Let's see an example in SAP. To recap what we've discussed, here's a snapshot of the planning situation for the test material in plant 0001. As you can see, the planning engine will always start with an available inventory quantity every single day. The first MRP element for any material will always be the current inventory quantity on hand. Looking at the exact same screenshot, let's now consider the reduction to available inventory due to scheduled demand. Keep in mind that safety stock is considered a demand signal or requirement element of MRP, and therefore will reduce the available inventory quantity. Here's a great tip. If the quantity in the receipt requirement column has a minus symbol following the quantity, then the MRP element is considered a demand signal or a requirement element. In other words, this quantity is required on this date for this task. Still in the same scenario, now see how the planning engine increases available inventory after each receipt element. If the receipt requirement quantity is a positive quantity, then the MRP element is a supply signal, or a receipt element. And each day, an expected inventory quantity will be determined after supply and demand signals are netted out. That's really all MRP is, a constant netting of supply and demand to ensure that when inventory is exhausted and demand cannot be met, then a receipt element will be generated automatically to replenish the inventory. When we discuss MRP in a general sense, we make certain assumptions that independent demand will drive dependent demand signals over a future planning horizon. But in some cases, that's just not possible. For whatever reason, a material cannot be forecasted or is considered a consumable item and will not be included on a bill of materials. And if not included on a BOM, then dependent demand will not exist for that material. So how do you make sure that you always have inventory on hand for these types of items? This is where reorder point planning is useful. For these unique materials, a planner will determine a reorder point quantity which is maintained on the material master record. This will be used by the planning engine instead of demand signals to automatically trigger a replenishment of inventory. Using reorder point planning requires a specific MRP type of VB. This is the standard SAP option, and customized versions of reorder point planning can also be configured for your use by your organization. It's also very important to understand that reorder point is not the same concept as safety stock. These are very different concepts and serve very different purposes. With the MRP type set as VB and the reorder point quantity defined, the planning engine will compare the available inventory to the reorder point quantity to determine if a replenishment is necessary. Once the available inventory drops below the reorder point quantity, as we see here, the planning engine will automatically create a replenishment element to return the inventory to the reorder point threshold. In this case, available inventory of 7 eaches is below the threshold of 8 eaches, so a purchase requisition was created for quantity 1 each to increase the inventory to the reorder point quantity of 8. And again, safety stock is not the same as reorder point. You can see in this example, the reorder point is 8 eaches and the safety stock is 2 eaches. The safety stock is there to ensure availability of the material during the procurement lead time required to replenish this material back up to the reorder point quantity. The point to take away here is that MRP and ROP both serve to ensure material availability, but do so in very different manners. And the fundamental difference between the two is that with ROP, the planning engine has no prediction as to when inventory will be used or consumed. Just that when it is used and the quantity drops below that reorder point threshold, a replenishment will be triggered. So things like toilet paper for your company would probably be planned under this method. It's very hard to predict when toilet paper will be used up completely, but you definitely don't want to be without some. So once your inventory quantity hits 8 rolls, or maybe a little bit more, a buyer would be alerted to get more so that you're never without. Now that we have the conceptual theory understood, let's apply the knowledge we've learned with a demo in SAP. This first demo will cover the make-to-stock scenario and will include the following: make-to-stock settings on the material master record, loading the make-to-stock forecast for the finished good, reviewing the planning situation before and after the planning run for the finished good and the BOM components, and finally we'll review the consumption of forecast once a customer order arrives. So let's get to it. Again, this first demo will focus on the make to stock scenario, and we will start this demo by taking a look at the material master record. To do that, we will launch MM02, enter the test material, the finished good that we will be forecasting. The field that we want is on the MRP3 view, so as long as you have that view selected, that's perfectly fine. And then you'll have to enter the plant in which you'll be forecasting the material under the make to stock scenario. Navigating to the MRP3 view, this view manages the demand planning functions within SAP for a material. So if you are not forecasting a material or the material is not relevant for demand planning functions, this tab would probably not be maintained at all. But we need to make sure that we've set that material up for a make to stock scenario. Otherwise, SAP is not going to understand how to plan it when it comes to demand planning. To do that, we must set the strategy group. You'll notice there are many options, and I'm not going to go into all of them. Again, right now we just want to focus on the two most common demand planning strategies, that is make to stock and make to order. And the strategy group for make to stock, standard SAP make to stock, is strategy group 40, planning with final assembly. But the strategy group is not the last attribute that we need to make sure is set correctly. When a forecast is loaded for a material under the make to stock scenario, consumption of that forecast is very critical. So as customer orders arrive in the system, the forecast quantity is reduced accordingly. That way you avoid what we refer to as doubling up the demand. You'll have the demand from the forecast and you'll have the demand from the customer order. The customer order should cancel out the demand that was forecasted or consume it. And to do that, we need to set the consumption mode. The consumption mode has 4 standard SAP options, 1, 2, 3, and 4. And each of these will control which direction on the time axis the SAP system will look for forecast to consume when a customer order arrives. The most common option is option number 2, which indicates backward and then forward. And that simply means that when a customer order arrives with a shipping date of some date in the future, the planning engine will first look backward on the time axis some period of days to consume the forecast. And if nothing is found, it will then look forward on the time axis to find forecast to consume. There is backward only, there is forward only, and there is forward then backward, which is the opposite of number 2. But number 2 is the most common option I've seen in most organizations. Now that consumption mode will simply affect which direction that on the time axis the system will search. The next 2 fields will define the number of days, business days, that the system will look in those directions. So the first field is the backward consumption per, followed by forward consumption per. As you can see, I have 30 days backward and 15 days forward. So when a customer order arrives in the system will look 30 days in the past to consume forecast, and if nothing is found, it will then look, or at most, 15 days in the future. So those are the only parameters that we need to set on our material master to ensure that we are able to load a forecast, and then that forecast will be consumed as we wish it to be once orders arrive. So saving those changes. The next task we're going to look at is actually loading the forecast. Now, standard SAP does that through transaction code MD61, but many organizations may have a custom program that takes an Excel file and uploads it automatically. This transaction does not allow users to load large amounts of data for large amounts of materials very easily and quickly and efficiently. However, this being a standard SAP class, I am going to demonstrate how to load a forecast for a material in SAP for the planning horizon. First, we must specify the material that we are forecasting. Then we will specify the plant that we are forecasting in. The version, I won't get into too much of that, but for now, the version will just be a 00 requirements plan. You could also have financial plans. You could have simulation plans, but the 00 is typically the active forecast that the planning engine responds to. And then the planning horizon. The from date will always be your current date, so whatever today's date is, that will start there at the from. The to date will be the end of your planning horizon as configured by your organization. And like I said before, it's usually anywhere from 12 to 24 months, most typically around 18 months. As you can see, this one is about 13 months roughly configured in this system. And then next is the planning period, which I'm going to load in a month because I do want to illustrate how you can automatically distribute a monthly forecasted quantity down into a weekly bucket very easily. From here, we'll simply hit the continue button. And SAP will navigate us into the planned independence requirement create planning table. Much of the information displayed on screen is what we've already seen on that initial screen. We have our planning start date and our planning end date. We have the material that we are forecasting, the plant, the MRP area of which we're forecasting, the version, the active indicator, and the base unit of measure for the material that we are planning to forecast. From there, you will see the period-based buckets in monthly buckets. The M stands for month. If you were loading this directly as weekly buckets, you would see a W, or even perhaps a custom calendar, you might see a C. And then it tells you the month. The period is March 2020, April 2020, so on, all the way out through that end planning horizon. You will also notice 3 tabs. The table tab, which we are defaulted to, is the planning table. The items tab will be an individual material. You can look at it in a slightly different view. And then the schedule lines. We will look at those shortly. But you are able to forecast multiple materials at once by pasting a list of materials in here and then pasting the forecasted quantities into the period buckets. Our demo will be simple. We'll just do the one material for clarity and ease of demonstration. So the first thing I'm going to do is start entering my monthly forecasted quantities. So as you can see, I started my forecast in April. Let's pretend this is a brand new material that we have never manufactured before. We have never sold it before. So this will be a brand new material, and we intend to start selling it on the market in April 2020. And these are the quantities that we are expecting or predicting or forecasting to sell to customers within these monthly periods. Now, monthly forecasting is very efficient. However, that doesn't help me when it comes to production planning. So I may need to break those down into a weekly period, at which point I can select that line and hit my Schedule Lines tab. You can see I have the same exact data displayed, just in a slightly different format. My material, my plant, my requirements type, the VSF, as we learned in our session earlier. The total forecasted quantity will be displayed as planned quantity, which you'll see is 2,150 eaches. That's my total forecasted quantity as a sanity check. And then it's broken down by schedule lines below in the grid below. And the M again indicates it's a monthly period, and the requirement date is the monthly buckets. If I want to stretch the first 2 months into weekly periods for production planning purposes, I can select those 2 periods and then click the distribution over a period button. And it will take it from this period to whatever period indicator you select. And in this case, I will choose weekly. And if you cannot manufacture half of an each, as I suspect you can't, I would recommend you putting in a rounding value so that it rounds it up to the nearest integer and doesn't give you a decimal. And when you hit continue, you will notice that those first 2 months have now been split evenly as possible with a rounding indicator across the weeks of April and May. And you can see that my period indicator for those that I converted has switched to a W. And instead of the month, I now have the calendar week showing. So week 14, I intend to sell 27. In week 15, I intend to sell 36. The last remaining buckets still remain in a monthly quantity because those may not be as exact as my first 2 months of forecasting. So that's really it. That's loading the forecast. This is telling SAP what we expect to sell and how much we expect to sell and when we expect to sell it. Again, it is a prediction. It is a placeholder for customer orders. You do anticipate orders coming in these quantities over these periods. So we will save that. The next thing I will demonstrate is the planning situation for that finished good that we just loaded a forecast for. Using MD04, the stock requirements list. Again, in our example here, this is a brand new material that we have never manufactured. We have never sold to a customer. This is what an initial planning situation will look like for a brand new material. We have zero stock because we've never manufactured it. And all we have right now is our forecast, our placeholder demand. And as you can see, those quantities that we loaded exactly match what we see here. And for the first 2 months that we split into weekly buckets, you will notice that they have weekly dates on them. The first day of each weekly period in standard SAP is always a Monday, unless the Monday is configured as a holiday for your organization. April 1st is an exception because it is a Wednesday. However, we loaded the forecast in April 2020, and April 1st is the first day of that monthly period that we started with. And then from there, going forward, it lands on the Monday of every single week. April 6th, you'll notice April 14th is a Tuesday. That's because April 13th is a holiday, Easter Monday. And in some organizations, Easter, if it's obviously on a Sunday, the organization will observe it on the following Monday. And then it resumes back to the Monday schedule with April 20th, April 27th, May 4th, May 11th, May 18th, May 25th. And then we're back into the June period where we did not load it into weekly buckets. If you're curious which holidays your organization has configured, you can click on any date field in SAP and display the calendar, and those highlighted in red are configured holidays. So as you can see, June 1st is technically a holiday in this system, which is why the June demand is landing on June 2nd. And then we pick up again at the first of each month, ongoing all the way through to the end of when I loaded my forecast. Let's look at the demand for one of the BOM components, and to know what those are, let's display the BOM using CS03. Test material is our finished good in plant 0001. As you can see, we have 2 components on the BOM, test component and test component 2. And to make 1 test material, I need 10 of the first component and 3 of the second component. That will be important when it comes to dependent demand signals. So let's just look at the before situation for the first component. As you can see, there is no demand hitting this material yet. Even though we have forecast on the finished good, we have not run MRP yet. The planning engine has not actually run in the system yet. So that demand has not been created. That dependent demand has not been created for the lower level components. So the only thing we have showing on this component is the fact that we have 100 eaches currently in stock. You can quickly switch back to a different material without exiting the transaction. Let's go back to our finished good test material. When I hit enter, it should return me back to my original planning situation for that finished good. And again, all we have right now is 0 inventory on hand and a bunch of forecasted demand. Now let's run MRP on this material, and we can do that using a quick button, which I have added to my screen through the user settings. The user settings can be configured under the General Settings tab. There are navigation profiles available for you to use, and there are many in the list, and even more can be configured by your organization. I personally prefer to use the MRP controller, and that's the navigation profile that I have. When I save that option, that is what controls these quick tools, these quick icons at the top of my planning screen. This one will run MRP at the finished good level and explode those requirements all the way down through the BOM. This is the screen to execute the planning run for a single material within a single plant, but it will explode down through all levels of the BOM. The results of the planning run, what we most care about are the database statistics. This will communicate what was actually done by the planning engine. And as you can see, we had 16 planned orders created, 48 purchase requisitions created, dependent requirements 32 were created. That is that dependent demand trickling down to those lower level components. And we had some capacity and lead time scheduling done, which we're not going to get into in this course. But that's exactly what I would expect to see after loading a forecast on this material and not having any inventory available to meet that demand. Returning back to my planning screen, all I need to do now is refresh my screen by clicking the refresh button. And as you can see here, the planning engine recognizes that we have placeholder demand in the system. The forecast is there, yet we have zero inventory available. So if we in fact intend to sell this material on these dates in those quantities that we forecasted, SAP is telling us we have to start making it. And that's exactly what it did. The system is proposing a planned order because this is a manufactured finished good, something that is produced in our shop floor. The planning engine created planned orders in the exact quantities to meet the exact forecasted dates that we have loaded into the system. So as you can see, we need 27. We need 27 eaches of this finished good available on April 1st because we expect customer orders to come through roughly near that quantity. So SAP has proposed a planned production order that would have 27 available right at that time, April 1st. So we're going to leave it at this point now. I'm also going to switch over to that component that we looked at earlier. I have switched over to that first component that was on the BOM for the test material, which is test component. And as you can see, I do have 100 in stock already. So I have some of what I need for that first order. But most importantly, look at the dependent requirements coming through the system from test material. And the dates that it's calculating are based on the lead time of the test material, when that production order is scheduled to start. And in order to have that inventory on hand in time, purchase requisitions are being cut ahead of it. Now, I have to make sure I convert those requisitions to purchase orders and get them here on time. But SAP, the planning engine, is doing everything it can based on the master data that we've provided to make sure that those purchase requisitions are cut and converted in time so that inventory arrives just in the nick of time. Now I want to demonstrate what happens to the forecast when a customer order arrives. And to do that, I'm going to show you MD73. Which will display the total requirements, the total planned independent requirements with any customer orders that are entered to consume them. So this shows us that test material has forecasted quantities over those periods. Some are weekly periods, some are monthly periods, as we've already seen, with a total planned quantity, a total forecasted quantity of 2150. Now, I don't have any customer orders in the system yet, so that section is blank. Let's create an order and let's see how the planning engine responds. As you can see, I've created an order for the test material for quantity 15 eaches to be delivered on 4/23. April 23rd is in week 17. So this should consume forecast in week 17. If forecast does not exist in week 17, the system should look backwards 30 days and then forward 15 days to find forecast to consume. So let's go ahead and save this order. As you can see, we now have order number 22162 has been created and saved in the system. The first thing I will do is go back to the planning situation for that finished good. So now you can see that we have 15, and let's now go look at the forecasting screen, the independent requirement screen, and see which week it consumed from. From here, I will simply refresh my screen, and now you can see my order is landed in the system and reduced week 17. Week 17 was originally 45 eaches. My customer order for 15 should reduce that week 17 demand by 15. So there should be a remaining forecasted quantity in week 17 for 30 eaches. Let's go back to our planning situation and see if we see that. Exactly. On 4/20, the VSF quantity is now reduced down to 30, whereas it was 45. But because the customer order has come in, the VSF has been reduced a bit in order for the customer order to take place. Just so we keep that demand the way we expected. We don't want to double up the demand. The last thing I want to point out is, again, coming back to MRP. What is MRP really doing? Consider it like a checkbook. MRP is simply netting the ins and outs. It's simply netting the debits and credits, or the supply and the demand, against the available inventory. And as you can see, we have available inventory of 0. We had a scheduled demand forecast that was loaded. And SAP recognizes by netting out that demand against the available that we would be below 0 unless we had some supply coming in to meet that demand. So SAP scheduled those receipt elements to come in order to have inventory available. Now, this doesn't mean that inventory will absolutely be available. That's not part of this discussion just yet. All we're doing right now is meeting demand with supply when inventory is unavailable. And that's exactly what MRP has done. It has scheduled those receipt elements to come in and be ready exactly when the demand says it would be needed. Okay, so to recap, this was a make-to-stock scenario. We looked at the make-to-stock settings on the material master record. We loaded the make-to-stock forecast for a single finished good. We reviewed the planning situation before and after the planning run to see how the planning engine responded to the demand without available inventory. We also looked at the component and saw how the dependent demand trickled down to the BOM components. And then we reviewed the forecast consumption once a customer order is placed into the system. Let's keep going. Now let's move on and explore the make-to-order scenario. This second demo will cover the make-to-order scenario and will include the following: make-to-order settings on the material master record, reviewing the planning situation before a customer order arrives, receiving a customer order and running MRP, and finally reviewing the MRP response to the customer order. Let's get started. Okay, so again, we're going to take a look at our second demonstration, which is going to cover the make-to-order scenario. And the first thing we're going to look at is the material master setup required to support this scenario. And I'm going to do that using transaction code MM02. Enter the finished good that is relevant to the make-to-order scenario. And again, like our last example, these settings are still on the MRP3 tab. So as long as you have that view highlighted, you're fine. And then specify the plant in which the finished good will be sold under the make-to-order scenario. Navigating to the MRP3 tab, we will again manage this through the strategy group. And in the last example for make to stock, we had a strategy group of 40. In this case, the make to order scenario requires a strategy group of 20. And there are several variations of this, but this is the standard vanilla make to order scenario, make to order production, where the planning engine will not respond to demand and it will not present receipt elements, production orders, in other words, until a customer order arrives in the system. And because this is using firm customer orders as the means for production as the trigger for production, we will not need any consumption parameters. The consumption parameters are only necessary if you have forecast that needs to be consumed. And in this example, make to order does not use a forecast. In fact, once the strategy group is set to 20, you will not be able to load a forecast at all. The system recognizes that that does not make sense for that material if it is planned under a strategy group of 20. So with that set, there are no further parameters that we need to set in terms of demand planning. Saving that material change. The next thing I will demonstrate is the before situation. Before a customer order arrives, let's just take a look at the planning situation for the finished good. We'll do that with MD04. Putting in the finished good and the plant. As you can see, we have none in stock, and we have no customer orders, and we have no receipt element. So there is literally nothing going on with this material at this point in time. And if I even wanted to, I could not load a forecast for this material. I could not put placeholder demand in the system. The system recognizes the make to order strategy of demand planning on this material. And therefore, we will not be prompted to make this material until a firm customer order arrives. So that is the next step of this demo. The system will sit here with zero inventory on hand until a customer order lands in the system. The next step of the demo will use MD04 to show there is no dependent demand on the components tied to a finished good using a make to order strategy. If you remember from our first demo, test component was the first component on that BOM for the test material. Because there are no receipt elements or planned production orders or live production orders in the system for the finished good, there is by default no dependent demand at the component level. The dependent demand is only created when receipt elements for the finished good exist in the system. So much like our finished good, our test component will simply have whatever is on hand, in this case 100 eaches of inventory, sitting there waiting to be used. The next step of the demo is to create a customer order, create demand for this finished good. And I will do that with standard SAP VA01. As you can see, I now have an order, and once I save, the order will be created in the system. I have an order for the finished good test material. The customer doesn't matter in this case. I have just any customer. What matters is that this material is make to order. The order quantity is 15. The order date, the order ship date is May 1st. The key element of a make to order is that you do not have this inventory sitting on your shelf ready to immediately fulfill customer orders. So your customers will be expecting to wait for the product to arrive. So whatever the lead time is for your material, that is what you should be using as a gauge for when you think you'll be able to deliver this to your customer. So I have future dated the order to May 1st, 2020, saving that order. And as you can see, we now have order number 22171 created in the system. So now I will go back to the planning situation using MD04 to demonstrate what the planning situation looks like for the finished good once a customer order arrives, but before the planning engine has responded to it. So as you can see, order number 22171 has landed in the system for a quantity of 15. And because MRP will immediately net out demand from available inventory, you can see that the projected available inventory on 428 is negative 15 eaches. So we currently do not have this in stock, and if we don't make it, we will not be able to fulfill this order. But the key point of a make-to-order scenario is, now that there is firm demand in the system, when we run MRP, the planning engine will respond to that by creating a planned production order. So let's run MRP next using our hotkey. And as you can see, the database statistics are the results of that planning run. 1 planned order created, 3 purchase requisitions created, 2 dependent requirements created. That are the 2 BOM components that this test material needs. 2 dependent requirements created. That's what we care most about. Navigating back to the planning situation, if I refresh my screen, I should see that the planning engine has responded to the demand, and it has. We now have a planned order in the system with an availability date exactly when we need that 15 units in order to ship it to the customer by the May 1st date that they requested. So that is exactly what I would expect to see on the finished good. We do not plan to make this material in advance. We will only respond to customer orders once they are entered into the system. Now let's take a look at one of the components. We should see dependent demand from the planned order. The planned production order should drive dependent demand to the BOM components. Navigating back to the first component on the BOM for test material, which is test component, you can see we did have 100 in stock, or we currently have 100 in stock. I need 150 of those components on April 27th. Therefore, we have a purchase requisition generated to procure the remaining quantity necessary to produce test material. The key point to see here is the dependent requirements coming from the finished good test material. So great. That is exactly what I would expect to see. Okay, so that was the second demo where we focused on the make to order example. And again, let's just recap. We started the demonstration by viewing the make to order settings on the material master record. We then reviewed the planning situation for the finished good and the BOM components to illustrate that no demand existed in the system, and therefore the planning engine was not responding by creating receipt elements. From there, we created a customer order and then executed the planning run. Then we reviewed the results and we reviewed how the planning engine responded to the firm customer order by creating a receipt element for the finished good. Then we viewed the BOM component to illustrate the dependent requirements that were created once the receipt element was created for the finished good. So let's keep going. Now let's move on and explore an alternative to MRP. This third and final demo will cover the reorder point scenario and will include the following. The reorder point settings on the material master record, reviewing the planning situation on the material planned under the reorder point method, consuming inventory, which drops the available inventory below the reorder point threshold in order to see how the planning engine responds. And finally, we'll introduce additional complexities to the ROP scenario through the use of lot sizing parameters. So that is what we're going to demonstrate here. The first part is looking at the material master settings. And we will do that through MM02. Enter the material number of the item to be planned as reorder point. And the settings we want at this point are on the MRP1 view of the material master. So if you have that active, that's all we're going to need at this point. And then, of course, specifying the plant in which it will be planned using the reorder point method. In order to tell SAP that the material should be planned using the reorder point method, you have to give it the MRP type of VB. The VB MRP type is a manual reorder point planning, and that simply means that you are manually determining what the reorder point quantity shall be. In this case, I have a reorder point set to 5. 5 eaches. When my available inventory drops below 5 eaches, the planning engine will automatically create a receipt element to replenish the inventory back up to that reorder point threshold. So other than specifying the MRP type as reorder point and then additionally setting the reorder point quantity, those are the only fields we need to plan with a reorder point. Again, I will introduce some additional complexities later in the demo around lot sizing, but for clarity, let's just keep the demo simple and just keep the reorder point and the basics of lot sizing. So once you have that set, you'll just save your material master. Before we go any further, let's just take a look at the planning situation for this particular material. We're going to do that using MD04, specifying the material that you are planning with the reorder point method along with the plant. As you can see, all we have showing in the planning situation is the available inventory on hand. Again, this material does not exist on a BOM, therefore there is no dependent demand out over the planning horizon, so the planning engine can predict when the available inventory is expected to be consumed and therefore plan future replenishments. That's not how this particular material is going to work. All we can do is keep track of what we currently have in stock, and when it drops below a threshold, trigger a replenishment. That is what we're going to do here. We currently have 11 in stock. I would also like to show that you can navigate to the header details by clicking the button next to the material, and it will expand the planning data that is maintained on the material master for that material. You do not have to navigate back into the material master to view this information. It's right here at your fingertips. And as you can see, the MRP type is VB, indicating it's planned with reorder point and not standard MRP. You can see that the reorder point is set to 5, and this item is procured from an external source. The procurement type is F, indicating that it is a purchased material. We currently have 11 in our building, and we need to order more as soon as inventory drops below 5. So how do we get inventory to drop so we can demonstrate this? For clarity of this demonstration, I'm simply going to issue some of the available inventory, some of that 11 eaches. I'm simply going to issue it out of stock to a cost center, indicating that it's been used. To do that, I'm going to do a goods issue, movement type 201, with a goods issue to a cost center. At this point, I have told SAP that I have used or I intend to use in the near future 6 eaches of this particular material, and I'm charging the cost of that to the production cost center. At this point, we will go look at the planning situation one more time before we run MRP, and we will do that using MD04. As you can see now, the available inventory, which was 11, has now dropped to 5. 5 is my reorder point. So let's run MRP and see if MRP responds. Just like our last example, I'm going to use my hot button to run MRP for this material. And according to the database statistics, no procurement proposals were changed. This means that the planning engine did not respond. Why would the planning engine not have responded? Keeping in mind that our reorder point is 5 and our current inventory is 5, the planning engine would not respond until the available inventory dropped below the reorder point quantity. So at this point, we are not below our threshold. We are at our threshold. So that was an important concept to demonstrate. If I consume one more each of this material, it should automatically trigger a receipt element when we execute the planning run. So let's do that one more time. I will use the MIGO transaction to process the goods issue. Again, still using the same movement type 201. I've now entered my component. I'm going to consume one additional unit of that material to force it below that reorder point. I have to tell SAP where the material is being consumed from, where in the warehouse is the material being consumed from. And then, of course, specifying the GL and cost center to which the cost of that inventory will be charged. With the goods issue posted and confirmed successfully, now we can once again look at the planning situation for this reorder point planned material using MD04. And now our available inventory is 4. And expanding the header details once again, we can see that that is below the reorder point. The planning engine has not responded because the planning engine has not been executed. Normally, in a normal environment, your planning engine is running at least once a day. And in many cases, in many organizations, planning engine is being executed multiple times a day. In this system, I have to manually force the planning engine to respond. And now, as I expect, the database statistics, which represents the results of the planning run, indicate that one requisition was in fact created, which is what I would expect. So let's return back to the planning situation. I will hit my refresh button. And you can see now that because the available inventory of 4 is below the reorder point of 5, I now have a purchase requisition created to bring me back up to the 5. So that is great. That is exactly what I would expect to see with this very basic, very vanilla scenario of a reorder point plan material. Okay, so that was a very vanilla, very basic example of reorder point. What you may have noticed, though, in that last example is that when the replenishment was triggered, it only created that receipt element for the quantity necessary to bring me back up to that reorder point threshold. So the next time I use that one piece, it would immediately trigger another replenishment order. So if you need to make sure that you replenish well above the reorder point that you have set, and then only trigger replenishments once you're below that reorder point, that is where we can introduce lot sizing. We're going to go back into our material master using MM02 for the material that is relevant for reorder point planning. The data that we're going to look at is going to be on MRP1. And of course, you must specify the plant in which it's relevant for reorder point planning. So as you can see, just like our last example, the MRP type is still set to the manual reorder point planning, which is the VB option. Our reorder point is still set to a quantity of 5. And all that is going to do is trigger a replenishment once available inventory drops below that quantity. If I want to make sure that I'm buying in efficient capacity, maybe buying a truckload at a time or a pallet size at a time, I can set my lot sizing data to account for that. And currently my lot sizing is set to EX, which is exactly, meaning when a receipt element is triggered by the planning run, it will be in a quantity that matches the exact quantity necessary. That is why we saw in the last example a purchase requisition for a quantity of 1, because we only needed 1 each to get us back to our reorder point threshold. If I wanted to manipulate that, I could do so through the lot size. As you can see, when I click on the drop down for lot size, I have 21 options, many of which are standard SAP, and your organization can configure new lot sizing options based on your organizational needs. By far, the most common is the EX lot for lot order quantity. And again, that just means when MRP creates a receipt element to replenish inventory, the quantity in which it creates that receipt element will be the exact quantity needed. No more, no less. However, there are other options, and we're not going to explore those too much today. I'm going to stay with the basic example of the EX. However, I will demonstrate that you can still manipulate that order quantity by setting a minimum lot size, a maximum lot size, and a rounding value. So if the supplier of this particular material requires that I order a minimum quantity with every purchase order, I can set that as my minimum lot size. And it is related to your base unit of measure. In this case, it's eaches. So let's just pretend that I have a 25 each minimum order quantity from my vendor. I may also have a maximum order quantity, either imposed by the vendor or the supplier, or perhaps imposed by my organization. Either one, that is where the maximum lot size will come in handy. And then if you need to round your order quantity to the nearest each, to the nearest 10, to the nearest pallet size, to the nearest truck size, whatever the case, you can ensure that your order quantities are rounded to the next whatever, in this case, 5 eaches. So if MRP determines that I need 27 eaches, 27 eaches has satisfied my minimum lot size quantity of 25, at which point, without a rounding value, I would get a purchase requisition of 27. But perhaps my vendor does not sell it in those types of quantities. My vendor only sells it in quantities of or multiples of 5. Therefore, I will set my rounding value to a 5 to make sure that if I need 27, I've met my minimum order quantity, but I'll be forced to order 30, which is a multiple of my rounding value. So with those extra attributes added to my reorder point scenario, I'm going to save those changes to my material master, and I will get a confirmation at the bottom of my screen that those changes were in fact saved. Okay, now that we have our lot sizing parameters, in addition to our reorder point defined, let's now look at MRP again. Let's look at the planning situation for that reorder point relevant material. And we'll do that using MD04. You should be pretty familiar with this by now. You'll put in your material number and the plant in which is being planned. And you can see we currently have available in stock. I have reset the inventory back as if our first demo had never happened. So, and again, expanding the header data, I can see that my reorder point quantity is 5. So as soon as I drop below 5, I will get a replenishment created. By navigating to the Lot Size Data tab for your material overview data, you can quickly see you're using the EX lot size procedure, along with the minimum lot size, maximum lot size, and any rounding values that you may have. You do not need to navigate into the material master to see this information. So as soon as my available inventory drops below 5, which I'll do next, I'll make sure we get the available inventory below that reorder point quantity, which again is displayed on the Material Master tab, reorder point quantity of 5. Once we drop below that, we should see a replenishment. So let's go ahead and do that. Okay, so again, I'm going to do a goods issue to a cost center for a quantity of 10. We currently have 11 in stock. When I do this goods issue for a quantity of 10, that would definitely drop us below that reorder point of 5, and we should see a replenishment triggered. So let's go ahead and post the goods issue. The confirmation that the goods issue posted is at the bottom in my status bar. Now we are going to go back to the planning situation for this material. And you can see now we only have 1 available in stock, which is definitely below that reorder point. And again, you can expand the header details by clicking this button. Our reorder point is 5, so as soon as the planning engine is executed, the replenishment will be triggered automatically. So let's do that using our navigation button. And as you can see, database statistics, which again is what MRP did, what did the planning engine do, and 1 purchase requisitions was created. So that is a good start. That is exactly what I would expect to see. Let's see if it created it in the quantities that I would have expected. Simply refreshing my screen, and there you go. The planning engine is trying to get our available inventory up to the reorder point quantity of 5. So why did the planning engine create a purchase requisition for a quantity of 25? Remember, our reorder point is 5, and right now all the planning engine is trying to accomplish is getting our available inventory quantity back up to that reorder point threshold. But to do that, if we navigate back to our lot size data, we have specified that we cannot order less than 25 eaches of this material, and whatever quantity is needed, it must be a multiple of 5. So we only technically needed to order 4. We have 1, our reorder point is 5, we only needed 4, but my minimum order quantity is a 25 each minimum, and that is a multiple of 5. So that is why the planning engine created a purchase requisition for 25 eaches. That is exactly what I would expect to see with the data that I have loaded for this material. Okay, so let's just recap that third and final demo. The final demo that we just completed focused on the reorder point scenario, which was an alternative to the traditional MRP planning method. In that demo, we reviewed the reorder point planning material master settings. We then went on to review the before planning situation of the reorder point component. Then we consumed inventory below the reorder point threshold in order to review the MRP response to the inventory drop. And finally, we executed that same scenario again with some additional complexities such as the lot sizing parameters. Thank you again for joining me today. Let's recap quickly what we've covered. First, we reviewed the planning functions at a high level. Then we discussed supply and demand and the intricate relationship between the two. Next, we took a deeper dive into understanding demand planning and MRP with some basic examples. And finally, we considered an alternative planning method, the reorder point method. I do hope you enjoyed your time and look forward to hosting you again soon.